A confirmation about the audio, please. If the audio is clear and available, kindly confirm the same. Thank you. We shall be starting in a couple of moments, guys. Few of the students are still joining us. Okay. So before the break, we were talking about the factors of frontal formation. How is it that the front gets created? And eventually, when you have the formation of a front, sometimes we observe the movement happening across the colder air, and that leads to generation of a cold front. We have taken a look at the type of weather patterns associated with a cold front. In the case of a cold front, the warm air is basically raised up or is forced up violently, almost vertically. And that means condensation happens in the same region at different vertical heights. So that basically means you will have the formation of a kind of a cumulonimbus cloud in general, right? So cumulonimbus cloud is associated with very heavy and violent rainfall. Significant amount of thunder and lightning events also are associated with it. Whereas when we talk about a warm front, in that case, again, the warm air is the one which rises up. In both the cases of cold front and warm front, if you would have observed, it is the warm air which rises up. But then, basically, the rise is different. In the case of a cold front, the rise is vertical. In the case of a warm front, the rise is very gradual and general. So that is why in the case of a warm front, you have a spread over cloud formation, which is spread over a larger area. Stratus kind of cloud gets created. And that means moderate and distributed rainfall, which can continue for a very long period of time, right? So that moderate rainfall can continue for a longer period of time. You won't have that much amount of thunder, rainfall, or thunder and lightning associated with that. So these are the things that we discussed. We discussed about the basics of the cyclone. Now we are going to discuss about the temperate cyclone before eventually coming over to the portion of a tropical cyclone. So now we initiate the discussion with the aspect of a temperate cyclone. The name in itself tells you that it is generally observed in the temperate regions of the world. And when we say the temperate regions, we basically are talking about the regions beyond the tropics, substantially beyond the tropics, that is in the mid latitudes. So, the region where these will be very common or very prominently observed. So, when you talk about the regions, so regions would be mid latitude. Right? Somewhere around 40 degree, 35 to 40 degree to roughly around 60 degree north and south. That will be the extent. 35 to 40 degree to 60 degree north and south. Now, these temperate cyclones, the image that you see on your screen is basically a top view of the cloud formation. So as you can observe, a kind of a circular formation of clouds. Obviously, why the circular formation? Because we have seen that in the case of a cyclonic circulation or the cyclonic formation, the winds, they come in, they rise up, and they rise up in a circular manner owing to Coriolis force. And that Coriolis force gives rise to that circular motion. Now, these temperate cyclones, they get created in areas where the fronts, they get distorted to such an extent that an extreme or an intense low pressure is created around the region of these fronts. Okay, I will repeat this. Listen to this carefully. These temperate cyclones are formed in those places where sometimes in certain areas the fronts get distorted to such an extent that you have extreme low pressure conditions created in the region of these fronts, leading to cyclonic formation. So if I were to write it down, so sometimes the front get distorted. And how is it that the fronts will get distorted? When we say that fronts get distorted, How can the fronts get distorted? From certain areas, you can have the warm air which starts pushing in. In certain areas, you can have the cold air which starts pushing in. So, what you basically gather as the shape of a stationary front, that shape in itself gets distorted beyond reckoning in general. So, the fronts, when they get distorted, right, severe low pressure gets created due to rising air. And that low pressure which gets created due to rising air leads to cyclonic circulation. So, what that means is basically frontogenesis is important. Not only important, is a must for this formation to happen, isn't it? For this formation, temperate cyclone formation to happen, frontogenesis is a must. Having said that, not all the fronts will develop or mature into a temperate cyclone, right? But no temperate cyclone can come into existence without the formation of the fronts. So let me encapsulate that as well. So, not all fronts develop into a cyclone. However, formation of a front is essential for cyclonic development. Okay. Now, frontogenesis basically is a must for the cyclone formation. So, in which season of the year will we experience more temperate cyclones to occur? During the winter or during the summer? What do you think? In which season of the year will we experience more temperate cyclones to develop? During the winter or during the summer? Okay. Ganesh, Parshuram, Kumari, Shilpa, Meera, Akshay, Satish, Anuranjan, Apurva. Could you also tell me the reason? Why do you think that is the season when the cyclone will develop much more frequently? Please let me know. Gaurav, you also. More temperature means what? Because ground will be heated much and air will rise up. But is that low pressure or the front formation here at all associated with the factor of insulation? Anywhere? Have we talked about the factor of insulation here? Understand, frontogenesis is a must for the cyclonic formation. In which season do we experience more frontogenesis to happen? In winter season. So if in winter you have more fronts getting created, so won't it be the case that in winter you can have more cyclones to be in existence? Right? Why in winter you have more frontogenesis? Because the difference of temperature between the warmer and the cold air is much more stark or much more significant during the winter as compared to the summer season. So that is why here, basically, this is something which will be much more frequent, much more prominent during the winter months. Okay? Much more Please understand, here we are not concentrating upon the thermal pressure. Thermal pressure, sometimes in isolated conditions, they exaggerate or exacerbate the impact of that low pressure. But thermal pressure is never the driver of the creation of this cyclone. It is the front. Okay. So much more frequent formation during winter due to higher rate of frontogenesis. I hope that is understood. Now, when you have a cyclonic disturbance which gets created, if you have to take a cross sectional view of it, let's suppose there is a cyclonic disturbance which gets created here. Let's suppose. Now, this cyclonic disturbance, will it be impacted by the surface winds in terms of the movement of the entire disturbance? Or will it be independent? Will it not be impacted by the surface winds? Does your common sense tell you? That this cyclonic circulation, the entire disturbance of it, will it be impacted by surface winds or will it not be impacted by surface winds? Correct? Perfect. Now let me come at the question that I was getting at. So they are impacted by the surface winds. So when we talk about these particular cyclonic circulations, will they be moving or will they be static in the same place? What do you think? Will the entire circulation be in motion or will it be static in the same place wherever it is created? It will be there only that the entire process will unfold. It will be in motion. What do you think will be the direction of motion of these temperate cyclones? North to south, south to north, east to west, west to east. Apply your logic. What will be the direction of motion of these temperate cyclones? Beautiful. Anuranjan, Pranay, correct. Satyanarayan, perfect. Madhuri, incorrect. Ganesh, Vidika, beautiful, correct. Ankit, correct. Good. So, I had asked you a couple of questions before arriving at the question about the direction of movement. Which were those questions? The question was that will they be impacted by the surface winds? The answer was yes. Now, will they be in motion because of the surface winds? Yes. So, in this region of mid latitude, what is the kind of surface wind which will be in existence? Are we aware of that? Let me know. What is the surface wind that is in existence between 35 to 60-degree latitude? Yes, Pranay, correct. What is 45, Madhuri? 45 is a very different answer as I was expecting. I am asking the question that in the latitude between 40 to 60 degrees north and south in both the hemisphere, which is the surface wind which is in existence? And by surface wind, I am talking about the permanent wind system. Correct. Abhishek, Priya, Ganesh. I expect all of you to give the correct answer in these cases. These are very simple ones. So basically, in these regions, you have the existence of a wind pattern that is the westerlies. And the direction of motion for the westerlies is west to east. That is why the cyclonic circulation also will be influenced by these surface winds and they will be moving in the direction of west to east. So the cyclonic disturbance cyclonic disturbance will be impacted by the surface winds that is westerlies, and hence move from west to east. Okay, I hope this is clear. Now, these are also what are sometimes referred to as wave cyclones or extratropical cyclones. Why? Because extratropical, it is happening beyond the tropical region. It is happening not in the tropical region, but somewhere beyond, hence extratropical. It is also referred to as extratropical depression. So when the low pressure is not very intense, where the wind speed is somewhere between 80 to 90 kilometer per hour, so that is not regarded as a cyclonic circulation. It is a depression. It is a low pressure, but not that acute. It is when that low pressure starts becoming significantly much more acute. That is when we call it a cyclone, where the wind speeds they cross 120, 130 kilometer per hour. They can reach up to 250 kilometer per hour to be termed as a super cyclone. But then why is it referred to as a depression? Low pressure if it has not developed. Why is it referred to as a wave cyclone? That is because it occurs across the region of the front. And if you notice, if you recall, rather, recall will be the correct wording here. If you recall the air masses that we had seen, and if you recall the shape at which the warm and the cold air masses they will meet, that does not represent a kind of a straight line. It represents a wavy formation. So let's suppose there is an extratropical cyclone developing here. So in the region of the front, it will develop. In the entire region of the front, as long as this front is continuous, let's suppose this front is continuous up till this point. So the disturbance might end up spreading across that distance for 1,000 kilometers or more. So that is why the overall diameter of this disturbance in terms of the clouds, etc., that is very high. The diameter of this entire disturbance, as you can see, this is the region of over North America, that can be very, very wide. The wind speeds are not as high as is the case with the tropical cyclone. But overall, they are formed across the fronts, and the fronts, because they have the wavy nature, that is why they are also referred to as wave cyclones. So here, a temperate cyclone is also referred to as a mid-latitude depression, extratropical cyclone, frontal depression, or even a wave cyclone. It happens beyond the tropics. It doesn't develop over India. India does not experience the genesis or the birth of a temperate cyclone. India will only experience the birth and the impact of a tropical cyclone. Okay. So temperate cyclones are active above mid-latitudinal region between 35 degree to 65 degree latitude in both the hemispheres. Right. So in mid-latitudinal region, in the mid latitudes between 35, generally associated around 40 degrees, but 35 to 65 in certain cases. Direction of motion is from west to east. Why? Due to westerlies, impacted by westerlies. See, understand one thing. All these things that you observe, direction of motion of the cyclone, where it occurs, its property, all of this might appear to be very complicated. But if you go to the root cause of it, does it move? If yes, why? Because of permanent winds. Which permanent winds? Westerlies. Does it occur in the mid latitudes? If yes, why? Front formation happens there. Why? Because you have warm air from the tropics colliding with the cold air from the polar region. Why? Because of the circulation system, tricellular model. So, all the very different types of complicated concepts that you come across, any time that you feel while revising, also the situation will definitely come. You will feel that certain concepts you are getting disconnected from. You are not able to understand those while revision. Maybe you would have understood it during the class, but during revision, you would not have understood it. So always understand, every difficult concept is derived from a set of basic parameters. So, ever in climatology that you find it very difficult to follow, always attack the basic modules, module 6, module 7. That is it. These modules, if they are clear in your brain, if they are clear in your mind, if they are embedded in your mind, there is no way why you cannot understand those complicated concepts as well. So, at any point of time, at any doubt that you have, look at the basics. What is the temperature difference? Why it is created? Rather than taking a kind of a random shot that you had offered two options, summer or winter, there is 50-50% probability. That should not be the approach. Okay. It is across these and along these latitudes that the polar and tropical air masses meet and they form fronts. That is why this is the mid latitudinal region where they are more prominent. If Himalayas are not lie on its place, then might it happen in India too? Very good question. A much deeper question than what I expected. Yes, the answer would be yes. If Himalayas would not have been present in the region, then especially in the months, that is from the month of December onwards, you could have the existence, or November onwards itself, you could have the existence of frontal formation in the northern part of India as well. Very good, Anuranjan. Now, let us take a look at the different stages of development of this temperate cyclone. We will cover this. Just a couple of moments, guys. There appears to be some issue with the sound. Just a couple of moments. Okay, hold on. Okay, I hope the audio is clear. So now we will be covering the various stages for the development and occurrence of the temperate cyclone. We will be observing the associated weather patterns in each of the cases, and we'll also try to understand how one stage leads to another, why is it, and when is it that you have the creation of that low pressure. We have seen the frontal formation, but we have never seen the creation or existence of a low pressure there. So, how does the low pressure get created? Because for the cyclonic circulation to develop, you definitely need to have that low pressure. So, it all begins, the entire process is initiated from the basic frontal formation. Frontogenesis is a must. Now, again, I will reiterate, temperate cyclone can never get created without the frontogenesis or frontal formation, but does not mean that all the fronts will develop into or morph itself into a kind of a temperate cyclone. Okay, so it all starts with the development of a stationary front. In the stationary front, you have warm air coming from one side, cold air coming from one side, right? And that is a stationary front. Now, at this point of time, no particular air mass, be it the cold or the warm, no particular air mass has got enough amount of energy to intrude into each other's area or territory, and you have the stationary front. Now, remember, if the stationary front persists for around 3 to 4 weeks, that means the air gets its time and its chance to dilute its properties and basically become a homogeneous mixture at the zone of transition. So, around 3 to 4 weeks, if this stationary front continues, then what happens is basically you come across a situation of frontolysis or death of a front. So here itself the front can get basically dissipated. But sometimes what happens, that this front starts morphing. This front starts changing its shape because cold air getting supplied from the high pressure, that is the polar high pressure, warm air getting supplied from the high pressure, subtropical high pressure. One is a thermal high pressure, another is a dynamic high pressure. Always remember that the thermal high and the thermal low, they are always going to be much more stronger as compared to the dynamic high and dynamic low in terms of their absolute magnitude, right? So as this pressure changes across both the ends, the cold air tends to push into the territory of the warm air, and the warm air tends to push into the territory of the cold air, right? Now what will it lead to? The front will get deformed, isn't it? So after this, if the front continues to gain energy, cold air pushes in to the region of warm air and vice versa. Now, in that case, what is the scenario that you will observe? Cold air pushing into the region of warm air and warm air pushing into the region of cold air. What is the scenario that you observe here? Distortion of the front. So, there you observe this. Cold air started pushing in, warm air has started pushing in. Eventually, as the cold air pushes in from this area, that will lead to creation of a cold front. And warm air, as it pushes into this area, this region, there you will have the formation of a warm front, isn't it? So here you will observe formation of a cold front. That hasn't exactly been formed at this stage, but it is leading to that stage. And here, initiation of formation of warm front. Here you have initiation of formation of cold front. Now, this further matures, cold air starts pushing in, warm air starts pushing into the region of the cold air. Now, as this continues to mature, you have a situation where the front gets distorted. So, when you have the simultaneous occurrence of both the cold front and the warm front. Now, if you think about it carefully, whether you have a cold front or whether you have the existence of a warm front, in either of the case, can we say that it is associated with the rising of air? Yes or no? Can we say that the cold front and the warm front, both of them are associated with the rise of air? Why? Because in both the cases, it is the warm air which gets pushed up. Some part of the cold air would also rise up along with that because of the air drag. But majorly, it is the warm air which is being pushed up. So as the front has gotten distorted, where on one side you have the existence of a cold front now, on other side you have the creation of a warm front now. In this entire area, you will observe massive rise of air because simultaneously both of them, they are rising up, they are leading to the rise of air. And when you have that large scale rise of air, what is the condition on the ground surface? It will create a low pressure. isn't it? Rising air, whether due to thermal conditions or dynamic conditions, it will always lead to a significantly intense low pressure. So, simultaneous existence of both cold front and warm front means substantial air is rising. That means it creates intense low pressure. Observe here, low pressure. This intense low pressure attracts more winds, because wherever you have the low pressure, it will also always start attracting the winds, isn't it? Now, which winds are we talking about? From this itself, from these regions itself. So from here it will start attracting cold, from here it will start attracting warm winds, isn't it? And these cold and warm winds, again they will be reinforcing the cold and the warm front, and again it will lead to the rise up. So reinforces winds will reinforce the cold and warm front, right? Leading to the entire process repeating itself. However, in this process, where this entire process reiterates or repeats itself in the sense that you have cold front and warm front intensifying, becoming much more intense, and cold air starts pushing on the ground, warm air is uplifted around the region of the warm front at the ground surface from all sides. Which is the air mass which starts dominating at the ground surface? Is it the cold air or is it the warm air? What do you think? Which air mass which will start dominating the ground surface? Cold air mass or warm air mass? Good. Almost all of you are correct here. It is basically going to be the cold air mass. Why? Because the cold air mass is much heavier as compared to the warm air. The warm air will be lifted up from the ground from all sides, whereas the cold air will stick to the ground. I will use an analogy from a piece of paper so that you are able to imagine it better. Think about this as a kind of a front, right? The incline that you observe. Think about the incline on the image, this incline that you see. Think about it as a piece of paper. Now, on this side, you have cold air. On this side, you have warm air. So, warm air is hitting it up, rising it. On the other side, the cold air is slowly and steadily encapsulating the ground around the region of the cold air, around the region of the cold front. Right? So, while in the region of the warm front, the cold air holds its ground. But from the region of the cold front, basically the cold air starts moving forward because it is sticking to the ground. Eventually, what will it lead to? The front, as you can observe, the front starts to close down, isn't it? From both sides, the front starts to close down. And as the front starts to close down, which will be the air much more prominent in the ground surface? Cold air. Cold air from all sides, because warm air is continuously getting lifted up. So that is where cold air becomes much more prominent on the ground surface. But at this stage of the mature phase of the cyclone, you will experience different weather conditions across the entirety of the area. Because we do know, wherever you have cold front, weather associated is heavy rainfall associated with thunder, lightning strikes, etc. Wherever you have warm front, you have steady rainfall, moderate rainfall prolonged for a longer duration. So, while in the region of the cold front, you will start observing the existence and the formation of cumulonimbus clouds, very strong heavy rainfall. In the region of the warm front, you will observe steady rainfall, stratus, nimbostratus kind of clouds being predominant. Okay, so this is the stage where rainfall starts to happen significantly. Intense rains are observed in the entire region, right? And winds also get attracted towards this low pressure. Now, always remember, a thermal pressure, be it a high or a low, is always going to be much more significantly powerful in terms of its magnitude as compared to a dynamic pressure. Always remember that. Whenever you have a thermal pressure, thermal high is, for example, polar high pressure is much stronger in its intensity as compared to the subtropical. In general, I'm talking about. And when you talk about, let's suppose, the ITCZ or the thermal low, equatorial low, that equatorial low is much stronger than the subpolar low. Okay, so that is how you have these pressures. So here, more and more cold winds are being driven from the region of the poles across and around this low pressure. As this starts closing up, as this starts closing up from all sides, means here you have the warm air and the cold air, or the warm front and the cold front starts approaching it. So in a way, the front starts to close up, right? So then you have the stage of beginning of occlusion, and this is because here front begins to close down. And why is that the case? That is because when we talk about these fronts, here observe this low pressure. So because, be it the warm front or cold front, the cold air dominates on the ground surface. So that means the region where you have the warm air on the ground surface, that region starts shrinking, right? Because even in the case of warm air, it is the cold air which sticks to the ground, warm air is lifted upwards, right? So the region of the warm air on the ground, region of warm air on the ground begins to shrink. As the warm air is uplifted. Okay. Now, in this stage also, basically, the cyclone will come into a kind of a closing stage at this point of time. Cyclone would have caused substantial amount of rainfall, associated wind movement from the mature stage itself. Here, it simply happens in close vicinity because the region of the cumulonimbus cloud is very close to the region of the warm front, that is the stratus cloud, right? Earlier, in the mature stage, the regional expanse of it would be significantly wider. That regional expanse would continue to shrink down as and when the front closes down. Eventually, you will reach the stage of occlusion or dissipation of the cyclone. Now, in that case, On the ground surface, what happens is basically, if you think about this as the front, on the ground surface, it simply closes up. Now, as it closes up on the ground, so all the warm air which was present is completely lifted upwards. So that means on the ground, you have a uniformity in terms of air temperature. Everywhere you have the cold air on the ground. So in that case, what is the resultant if on the ground you have the same type of air? Frontalysis. The front will no longer be in existence because now the front has closed down. So that is the end of the cyclone. That is the stage of dissipation of the cyclone. So here, the front closes down. Cold air covers the entire region. The front closes down. So as the front closes down, that means you have frontalysis. And end of cyclone. So this is your temperate cyclone, the process of creation of these temperate cyclones and the stages of development of these temperate cyclones. So here again, I will recap it very quickly because why I want to reiterate this again and again, because these are the portions that if you study it in the book, from the book, any book of your choice, right? I'm not only directing you to one book, any book of your choice. If you study these topics from the book, it will never be clear, because generally the books, they take it as an assumption that you would know all the various details like a geographer, and that is where you are unable to imagine it on a larger scale, that how will it happen, where is it that the front is being talked about, and even the images there which are put forward in the books generally are not three-dimensional. So that is where you will have a great difficulty if you are having that target, that right now let us just brazen get through it and eventually we will revise it sometime later. No, that is where it will lead to much confusion. So let me repeat it once again: the entire stage of the formation, the process of generation and germination of the cyclone. So these temperate cyclones, they get created in the region of the mid latitudes, that is between 35 to 60 degrees, 40 to 60 degrees north and south in both the hemispheres. Now, they will be in existence only when the fronts get created and the fronts get distorted. Normally, the fronts can get in existence and it can lead to frontalysis also. So that will not develop into a cyclone. So not all the fronts lead to a development of a cyclone. But for the development of a cyclone, a front is a must. Okay. Now, it all starts with the cold air and the warm air confronting each other. At that particular point itself, you have a stationary front. Now, stationary front means the cold air will have its own shape, warm air has its own shape. Now, slowly and steadily, when we are talking about the cyclonic formation, slowly and steadily, the cold air starts pushing into the region of the warmer air, and warmer air starts pushing into the region of the colder air. Now, that leads to the simultaneous formation of both warm and cold front. So, here, simultaneous formation of both cold and warm front. Okay, that is something which will be observed in that case. Now, in the case of a cold front, what do we have? We have a sudden vertical uplift of the air. In the case of a warm front, what do we have? A slow and steady rise of the air, isn't it? So cold front will lead to what weather conditions? Absolutely very high rainfall, very significantly intense rainfall, and formation of a cumulonimbus cloud associated with thunder and lightning. And when we talk about the region of warm front, moderate rainfall, gentle rainfall, no thunder, no lightning. But when both these fronts they start getting prominent, that means in that entirety of the area, you have massive rise of air which is happening. Warm air is rising up from both these areas. Now, as the air is rising over a larger area or a larger region, on the ground surface, the impact of that rising air will be creation and existence of a low pressure. That low pressure will be very prominent, isn't it? Now, when you have the prominence or the existence of a low pressure, if I can take you back again to that particular slide, let's suppose here, because you have the creation of that low pressure, let's assume here you have the low pressure which gets created across this region of the front. So that means winds will be attracted from the polar regions also and from the tropics also. Now, all these winds, they will reinforce the warm front and the cold front simultaneously. So, in a way, the impact of this cyclone will begin to intensify. So, more air will rise up, means significantly much greater low pressure, which means what? More winds will be attracted, more will rise up. This process will intensify the cyclone as the low pressure becomes much more intense. In that case, you will have much greater amount of rainfall, stronger wind movement associated. It is these wind movements, when you hear the news stories that a cyclone has struck, let's suppose, the region of UK, right? You will hear that it has caused substantial rainfall, or it is raining in the region of Western Europe for 5 days, 10 days continuous. Or when it hits the northeastern part of, let's suppose, US. So there also you will observe that it has been raining continuously. You have some wind movement, but not that strong. So that is something which is associated. A continuous rainfall over a very large area, maybe 750 kilometers in terms of its diameter, 1,000 kilometers in terms of its diameter. But the low pressure continues to intensify. Sometimes, by the way, this intensification of low pressure happens at such a quick pace that you have the low pressure, the pressure of it, falling by more than 24 millibars in the same area within 24 hours, within 1 day. So when you have such sudden intensification of low pressure, wind speeds become explosive. Wind speeds, they cross the expected parameters and the expected lines. Obviously, the destruction created will also be quite significant in those cases. So that is when even the prediction mechanism which is done, even the scientists, they are oftentimes surprised by this intensification. And that suddenly intensified cyclone that you observe, that is what is referred to as bomb cyclone. We'll come to it later. So that is how the intensification of the cyclone takes place, bringing rainfall and the disturbance and the wind pattern in the surrounding. But all the meanwhile, it is the cold air which starts engulfing the ground surface nearby. It is the cold air which starts surrounding the ground surface nearby. Because even in the warm front, you have cold air on the ground. Even in the case of the cold front, cold air on the ground. And more winds getting attracted means more cold air being pushed in. More cold air being pushed in means the cold front expands. If more warm air comes in, the warm air will rise up straight forward. It is not the case that if you are here, you have cold air, warm air is coming in, it is pushing back the cold air. No, it will. More warm air means more rise up. So the cold air holds its ground. And on the other side, where you have the cold front, it starts gaining ground. So that means what? That basically means that the front starts to get smaller. And that is the beginning of the stage of occlusion. That is the beginning of the end, if you can call it. So the front gets much more narrow. Observe the cold front and basically the warm front associated. They get much more closer, right? So that is where you observe all the disturbance activities happening in a smaller area. Earlier it was happening over a much larger area. Now it is getting restricted to a smaller area. Eventually, what will this lead to? Eventually, a stage will come where on the ground surface you will only have the presence of cold air. all the warm air would have been lifted up. And that is when you have the final stage or the dissipation of the cyclone, what is referred to as the late occlusion or dissipation, where the front in itself closes down. Observe the front in itself getting closed down. So, after this, what will happen? After this, you will have maybe the creation of a new front somewhere else, but here that low pressure will disappear. Why? Because in this region, you will not have the air rising up anymore. Why? Because there is no front in that region anymore. So that is when, as the cold air covers the entire region, the front closes down. This is what is the occluded front, and that is what is frontolysis and the end of cyclone. Okay? That is the aspect of the entire process of cyclonic formation. I hope this is now understood. Is it understood? Okay, I have a host of questions. Let me address these questions one by one. Okay. And as and when your questions get cleared or your doubts get cleared, please let me know that whether the doubts are still persistent or whether it is clear. So I have a question by Priya. What will be the region of change in atmospheric condition will experience? The range. Okay, so you are talking about the diameter of that disturbance. It can vary from right from 500 kilometers in diameter up to 1,000 kilometers. It can be very wide. And Kumari, these all are stages of cyclone. Yes, my dear innocent friend, these are basically the various different stages of a temperate cyclone. Uh, Anuranjan, correct. Pranay, correct. Gaurav, sir, in which part of India cyclones are observed mostly? Okay, you have a different question altogether, Gaurav. So, in India, you observe cyclones in the region of the coastline. That is where you experience it, right? But temperate cyclone is not formed in India. I hope that is something which is clear in your mind. Temperate cyclones are not formed in India, right? India is impacted by a tropical cyclone. I hope that is clear in everybody's mind. And Madhuri, I have NCRT, best book out there. Priya, in stage 4, you said nearby region experiences. So, in that range, that will experience change in warm and cold air. Priya, okay. Priya, I hope your doubt is cleared now. And Kumari, what is meant by a front? Kumari, wherever you have the transition between the cold and the warm air, that is where you have the frontal formation or the existence of a front. You have different types of front. So, in case you have missed it out, you can take a look at the recorded lectures. Blizzard can influence these fronts? Absolutely, yes. They can suddenly provide impetus to the cold winds coming. Yes, correct, Pranay. Mira, front is necessary for both temperate and tropical. In the case of a temperate, absolutely yes. In the case of a tropical, you have a different type of a front that is between the warmer air, moist air, and less moist air, which is almost horizontal. So, in the basic references, if you talk about it, then it is not absolutely necessary for a frontal formation in tropical. But if you take a look at it from a purely geographical academic point of view, then yes, there also you have a different kind of a front. And occlusion front will always lead to cyclone. Ankit, occluded front is amongst the final stages before the dissipation of a cyclone. This is your stage of the occluded front, right? The stage 5. It is the last stage when you have the formation of a cyclone. That is your occluded front. Does that mean if we can provide artificial cold air from nearby, does it occlude earlier? In future, if we are able to do so by advancement of technology, that also means that if you push in cold air quite significantly, that means it can lead to much more violent weather condition because you are pushing in or making the cold front much more stronger. So if you have to talk about the hypothetical extent, the way to end this front or the cyclone immediately will be to end the front. And how do you end the front? By removing the temperature difference. So if you warm out this area, that also will lead to the end of the front. Okay, I hope that answers all the questions. Okay, no, I have a couple of other questions. Akshay, how to go through maps for Indian subcontinental cyclone and world cyclone? You don't need to go to for the map of that. Who told you need to go to the map of the cyclones? No. Which regions to prepare for cyclones in the world that are very prominent to come in the mains exam? Have you taken a look at the mains question associated with that? Or is it out of pure imagination that you are creating these mains question? Mains in UPSC mains, you will never find a question that, for example, show the path of the cyclone Tej or show the path of cyclone Midli. No, even the best of the climatologists won't be able to do that. You need satellite data in order to pinpoint that. Mains, you will never get those kind of questions. Mains, the only question that you will get, how these cyclones get created, what is the process of formation, intensification of the cyclone, what is the impact of these cyclones. In case of tropical cyclone, the formation is very different, and that is why destruction associated is also very significant. So how is it that the tropical cyclones are named? Those kind of questions will be asked. These are stages of temperate cyclone only. Tropical cyclone formation has a different stage of formation. Yes. Okay. So what I gather is that most of you somehow you are waiting with bated breaths for the tropical cyclone to come in. But let me tell you, tropical cyclone, I understand it is very, very complicated. I will try to simplify it as much as possible. But understanding the temperate cyclone is going to be a hard nut to crack. So, as of now, if you have understood the process of existence and formation, the region of existence of these temperate cyclones, that is something which you should be very happy about. Okay, because, and what I would also suggest to you, immediately after the class, please ensure that in a piece of paper, you write down, you try to recall this process of formation. Okay, please don't leave it for 1 week later or 5 days later. You might forget one stage in between, and the entire concept will come crumbling down on its base. So try to write it down. Think about it as if you are trying to explain it to some of your student, right? You take my role in that case, make the piece of paper your student and try to write it down, put it down on a piece of paper. That piece of paper, one A4 sheet paper for temperate, one A4 sheet paper for tropical cyclone. That is all that is required. If you do it today, trust me, even next year or year after that, if you are appearing for the mains examination, all that you will need to do is flip through that piece of paper within 5 minutes, the entire concept, which worries your competition. Almost all the people who are competing for the examination, 99%, if you ask them that, have you understood the formation of a temperate cyclone? They would have learned whatever is there in the NCRT. If UPSC goes ahead to ask a conceptual question, they will be on their back. So that is where you will have the advantage, provided put in some amount of work from your end also. Okay. And Priya, I have an associated question from you. You teach it, when you teach, it seems so easy, but afterward it feels hard. Why? How to overcome? How to memorize all this? First of all, believe, trust yourself, trust your mental skill. And I think I have said it before, something that I gained from my teacher back in the school days, where that person was still a very renowned teacher for the subject of chemistry. He basically told us that any of the concept, when I'm telling you, if you are able to understand, that means your mind has the capability to think about it on its own. So have faith and have the belief that any of the thing that you have already understood, that means the mind can recreate it on its own. The only problem is few of the pieces might be missing here and there. So in that case, the solution to that is immediate and quick revision. If you pick this up, On Friday, next Friday, before coming to the class, trust me, there will be a lot of loopholes. If you pick it up today, latest by tomorrow, there won't be loopholes. But by tomorrow, you will also have to, I will also ask you to write down the Indian monsoon portion, because Indian monsoon is much more complicated, or equally as complicated as this, if not more. So try to finish it within the couple of days and write it down in your own words. Put it down in your own words somewhere down there and just keep looking at it, right? I have seen many of the toppers follow the strategy of maintaining such A4 sheet paper file, very short one, where all the complicated concepts, they would note it down, including the facts and the factoids, and they would revise it regularly every 7 days to 10 days interval. So by the time that you appear for the prelims or the mains, all those concepts that you found it very difficult to remember, that is almost cemented in your memory. So that quick revision within the 7 to 10 days, follow that and trust your skills. That is more than sufficient. Okay. After stationary stage, how the front gains more energy? So as I told you, where does the energy come from for the winds? From the high pressure. Which high pressure? Thermal high pressure at the region of the poles and dynamic high pressure at the region of the tropics. Both of them. Now, if let's suppose these high pressures are not that strong, so the front will not develop into a cyclone. It can lead to, the stationary front will lead to frontolysis, or maybe a cold front or a warm front will be created, and that is it. But if let's suppose from both ends the high pressure gets stronger, it can get stronger. The high pressure gets stronger. And why? Because of wind movement and subsidence of the wind and so on. So then you will have the distortion of the front, leading to the formation of a cyclone. Okay. Utsav, I hope that is understood. Okay. Now, as I told you, sometimes the low pressure which is created, that intensifies all of a sudden and quite significantly. So that means the wind velocity will speed up. Because remember what we had discussed last week, when you have the pressure gradient, that is the difference between the high pressure and the low pressure. If the pressure gradient is high, that is the difference between high and low pressure is significant, the wind movement will be strong. If the pressure gradient is less, wind movement will be less. So, as the low pressure suddenly intensifies due to massive uprising of the wind, vertical movement of the wind, that sometimes leads to sudden and drastic fall in the region of the low pressure. And that means more winds are attracted towards this low pressure with very high velocity. Not only will it bring much more violent conditions of rainfall, thunder, and associated phenomena, it will bring a lot of damage and destruction in its wake. Right? In the region across the coastline, the waves, they become much more stronger. It can lead to coastal flooding, as these strong winds, they drag the sea water or the oceanic water across the land areas. And the destruction, the floods, etc., which are caused, are significant. So, such intensification of low pressure, where there is a drop of 24 millibar or more of pressure within the span of 24 hours, that is what is referred to as bomb cyclone. Right? Why? Because when we talk about bomb is associated with an explosion. Here you have sudden explosion in terms of the characteristic of the cyclone. Earlier, you had a smoother wind movement, gentle wind movement. Suddenly, it becomes very strong within one day. Its impact is much more significant within one day. And hence, it is associated with the events of that of a bomb explosion. Hence, bomb cyclone. And it is a powerful, rapidly intensifying storm associated with a sudden and significant drop of atmospheric pressure. So the sudden intensification of low pressure kicks in a very rapid development of a cyclone, and that is referred to as bombogenesis or explosive cyclogenesis. Right? Genesis refers to birth. So bombogenesis, birth of a bomb cyclone, or explosive cyclogenesis, basically explosive cyclone gets created. Okay? right? Why the pressure drops uh, suddenly? The pressure drops so significantly suddenly because of the rise of air. Remember the mature stage where we talked about the fact that there is rise of air. Now that rise of air leads to low pressure. Sometimes what happens is, as more air is fueled in from the nearby regions, you have more pushed rising up, which means that the low pressure becomes much more lower in terms of the pressure exerted. Sometimes you can have thermal factors also integrating with that low pressure. So that can also lead to bombogenesis. Millibar, Gaurav. Okay. Now, then we come to the cyclone that all of you were basically concerned with, and all of you have all your doubts associated with, and that is tropical cyclone. It is a tropical cyclone which impacts us in India. It is a tropical cyclone, which we hear all about from our childhood days. Whenever you had basically gained the awareness or the thought process to process what is a cyclone and India is getting impacted by the cyclone, you would have heard about the tropical cyclones. Now, tropical cyclones, as you can observe from the satellite image, they have, in comparison, a much lesser aerial spread as compared to a temperate cyclone. But here, this tropical cyclone is created because of a thermal low pressure, and hence it is much more stronger. It has much stronger wind movement. So the destruction caused, the destruction created is quite significantly large, very, very high. Okay, so that is basically associated with a tropical cyclone. Now, tropical cyclone does not occur anywhere and everywhere. It is not the case that it can happen in my backyard also, it can happen anywhere. A temperate cyclone can develop over land as well as over water, but a tropical cyclone will develop only above the water body. A tropical cyclone will never develop over a land area. Why? We'll come to that within a few moments as we move ahead in discussion. You will understand that. But always above the water body. And by water body, I mean seas and the oceans only. So, water bodies of the tropics is where you experience this. Yes, Pranay, correct. So, forms only above tropical waters. Last weekend, we had talked about the latent heat of condensation. I hope everybody is clear with what is latent heat of condensation. That whenever there is any process of condensation happening, there is an associated heat which is released in the process. And that is known as the latent heat of condensation. I hope we are aware, we are comfortable with that. Anyone having any doubt in that latent heat of condensation? Good. So I will repeat it very quickly, very soon. So when we talk about latent heat, that is the amount of heat which is consumed by any state of matter or released by any state of matter in when they are changing the state. That is when they are changing from, let's suppose, ice to liquid water, from water to gas or steam. So there is a requirement for change of state, because in solids the particles are arranged differently. Liquid water has got particles arranged differently, and steam or gas has got particles arranged differently. So whenever you have solid getting converted into liquid, liquid getting converted into gas, there is substantial amount of heat which is consumed in the process without showing any change on thermometer readings, because that heat is gained by that matter in order to loosen the bonds between the atoms and molecules and so on. Similarly, when we talk about the converse of it, so whenever you have the steam condensing into liquid water droplets, liquid water getting condensed into solid, anytime when there is condensation, there is rebuilding of that bond. So in that process, they release heat. Okay. So when we talk about latent heat of condensation, of condensation heat released during the process of condensation as the matter changes state from gas to liquid or solid. Okay? Because this latent heat of condensation is an important parameter in the entire process of formation and the sustenance and, in fact, the intensification of the tropical cyclone. Now, tropical cyclone is not something which is only experienced in India. It is experienced almost in the tropical waters across the globe, right? So, wherever you have such intense low pressure in the tropical waters, you can experience the existence of a tropical cyclone. Generally, in southern Pacific, in southern Atlantic, you don't have that much persistence of that low pressure. That is why those are the areas not very frequented by it. But northern Australia, western part of Pacific, that is South China Sea, when you talk about Gulf of Mexico, these are the regions which are frequented by these cyclones. But these cyclonic events, when they happen in different parts of the world, they are named differently. Okay, so when we talk about these tropical cyclones, they are known as cyclones in the Indian Ocean. When they occur in the Atlantic, they are referred to as hurricanes. When they occur in West Pacific and the region of South China Sea, they are referred to as typhoons. And when they occur in the region of Western Australia, they are referred to as willy willies. So they occur and are observed across a larger area, but they are named differently. We are basically concentrating upon the cyclones created in these areas. Northern Indian Ocean, they are named as cyclones. And by the way, I understand many of you have the habit of frequently going through the previous year question, which is a good habit. But many of you immediately will start asking questions that why is it that Bay of Bengal has got more occurrence of cyclones as compared to Arabian Sea? I would advise you wait for a few moments or few classes. Let us cover the portion of associated oceanography as well. By the time that we are finished with all the portions of oceanography, let me assure you, you will get a much clearer concept of why is it that Bay of Bengal is much more frequented by tropical cyclones as compared to Arabian Sea. We will not be rushing to the answer now because there are much different concepts associated with the oceanic water, associated with what happens in the Pacific, etc., which leads to these conditions. So that tells you how interconnected the climate of the world is. Okay, so the answer for that we will get around maybe by late tomorrow or maybe next Saturday. Okay, now is that heat works as an engine for the cyclone? Yes, Justin, correct. Now, not all the low pressure or not all the thermal heating will develop into a cyclone, a tropical cyclone. A tropical cyclone requires certain conditions to be fulfilled, certain parameters to be met. So, what are those conditions which are absolutely required to be fulfilled for the generation of this tropical cyclone, the genesis of this, and the formation of this tropical cyclone? So, you have varying conditions. First of all, you need a large sea surface with a temperature higher than 27 degrees Celsius. Why that temperature higher than 27 degrees Celsius? That is what is required for the creation of low pressure. As we speak, there is a cyclone which is developing in the region of Arabian Sea, roughly around 9 degree north, roughly around 61 degree east, longitude and latitude. That is where a cyclone is developing in Arabian Sea. And you would be surprised to know that the temperature of Arabian Sea in that region is around 31 degrees Celsius. So when the temperature of water in an area increases, and why will it increase? How can it increase? Because of impact of solar insolation, wind movement, etc. All of them contribute to the rise and fall in temperature. So when that gets heated up, a low pressure gets created. And that low pressure can intensify into a tropical cyclone if all the other parameters and conditions are met. First of all, there needs to be presence of Coriolis force. Because unless and until you have a Coriolis force in existence, you will never be able to attain a circular movement of the wind. In the case of lack of Coriolis force, if let's suppose you have a low pressure which develops, the winds will come, they will rise up, form clouds, bring rainfall here itself. That's it. But if you have a Coriolis force, you will have a circular movement of the wind, right? So this is the reason why no tropical cyclone will ever get created at equator. This is the reason why no tropical cyclone ever crosses equator. Okay, so hence no no tropical cyclone is created at equator or crosses equator. Okay, now small variation in vertical wind speed, what is also referred to as wind shear. What is that? Let us understand it. So basically, when we talk about any region, let's suppose we talk about any region here. Now there will be wind movement here also. 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 But if let's suppose the upper air wind is moving at a very, very high speed and the surface wind is moving at a slow speed, in that case, what will happen? Let's suppose the upper air wind is moving at a very high speed. So any cyclonic circulation leading to cloud formation, for example, that cloud will be blown away by the wind immediately. Whereas in the lower region, you will still have that cloud and the formation of some cloud. So the entire cyclonic disturbance will not be created. That is why at different heights, the difference between the wind speed should be minimum to allow the entire formation of the cyclonic disturbance. So in the region of formation difference of wind speeds at the surface and upper air should be minimal to allow for the cloud formation. Complete cyclonic formation. So that should be the case where the difference between the wind speed at the surface and the higher up, that difference should be minimal. Okay, so here basically means that the speed of wind movement at the lower surface and the upper air, as long as it is similar, the cyclonic circulation will develop. There needs to be a pre-existing low pressure area over that water body that can intensify into a cyclone. Okay, so these are the required conditions. Now let us understand how is it that the formation process actually happens, the formation of a tropical cyclone. Okay, now let's assume a large water body which is actually required for this. So let's assume you have a water body here. Now, it is this water body which will get heated up in a certain area or in a certain region. Now, let's suppose you have a particular area where this gets heated up in this region. You have the creation of low pressure. Let's suppose. Here you have the creation and existence of low pressure. Now, when you have the existence of low pressure here, means what? It will attract winds from all sides, isn't it? So it will attract winds from all directions. Now, as the winds are getting attracted, these winds, can we say, they will be warm and moist. The moisture level will be very, very high for these winds. Why? Because they are coming over from the region of the water bodies. So the moisture level for these winds will be very, very high, isn't it? Now, all these winds, if the moisture level is very high, means what? Slightest amount of cooling can lead to saturation and quick condensation. That means condensation will be very, very quick in these cases. But nonetheless, the wind comes here. It comes here. And this also gets heated up. This also gets heated up. Now, when this gets heated up, it will begin to rise, isn't it? So here, it will begin to rise here. But will it rise in a straightforward manner? No, it will rise due to the Coriolis force in a spiral manner. That will be the rise, a circular manner almost. So the rise of the wind will be somewhat in this manner. This is the direction of the wind as it is rising. So as it is rising, its temperature will start dipping almost immediately. And as the temperature dips almost immediately, basically, condensation will happen. Very close to the ground surface itself, condensation will begin to happen. But nonetheless, let us assume that the wind continues to rise up. Now, condensation would happen. How? So the wind is rising like this in a circular fashion. So all around that circle, because that is where the wind is moving, that is the direction of the wind. Had the wind been moving straight forward in a straight fashion, condensation would have happened one on top of each other. But the wind is rising like this, so condensation will also begin to happen in a circular manner. All around it, condensation will happen. Here, condensation will begin to happen from here itself. On the sides, condensation will happen. Okay, here also on the sides, condensation will happen. It will develop into kind of a circular manner, obviously, because it is a two-dimensional image. I can only do so much. But if you take a look at this image, condensation happens all around the circle as the wind is rising up, isn't it? Now, as this condensation is going to happen, this is going to be a cumulonimbus cloud basically, because condensation is happening at different levels. Now, as that is happening, there will be, in the process of condensation, substantial amount of latent heat which will be released. Now, where will the latent heat be released? Wherever condensation is happening, there it will be released. Where is it that the condensation is happening? in the path of the rise of the wind. And what is the path of the rise of the wind? Circular motion is the path of the rise of the wind. So around that condensation is happening. So that is where the latent heat of condensation will be released, isn't it? So all that latent heat of condensation will be released into this area. So this is your release of latent heat of condensation. Okay, the release of latent heat of condensation. Now, when you have that release of latent heat of condensation, what will be the temperature in the central portion? The temperature will go up in this area, isn't it? All that heat will be accumulated in the central area. So the temperature will go up in this region. Now, in the meanwhile, there is something else which is at play. Now, for that, I want you to understand the fluid dynamics. Remember, from the first day itself, I'm telling you that the air movement significantly follows almost a similar principle as a fluid movement. So, when you have the fluid thing that you would have, fluid mechanics that you would have observed, that is in a bucket. If you have a bucket full of water, I'm sure most of you would have done that at some stage of your life or the other. If not, it is high time that you do it. If you try it out. If you have a bucket full of water, have you ever tried rotating that water, keeping your hands on the sides of the bucket and quickly moving your hands in a circular motion? What is it that you generate? You generate a circular movement in that bucket of water. I'm sure most of you would have observed that, experienced that. So, what happens in the central portion in that case? What happens to the water level in the central portion in that case? Have you observed? Water level goes down, isn't it? Always when there is a very substantial, rapid movement at the sides, in the center, the water level goes down. What happens in the sides? Does the water level remain the same, or does the water level increase and spill over? What is it that you have observed across the sides? It increases, right? If you continue to rotate it significantly, if you fill the bucket to the brim, try it out today itself. Fill the bucket to the brim, to the top, and rotate your basically the forearms in that water. Give it a quick circular whirl and observe what happens. While on the sides, the water level increases. In the center, it basically undergoes a kind of a depression. It sinks, right? So something very similar happens in the case of this rising air on the sides. As the air continues to rise up with a substantial amount of velocity on the sides, in the center, there will be a suction, there will be a depression. So, in the central portion, what you observe is basically going to be a sinking air column. Here you will observe sinking air column in the center. Now, as this air column is sinking, what will happen? It is going to go into the region of higher air density. There will be adiabatic compression. It will also accumulate all the latent heat which was already being released into the central portion. So all that heat gets accumulated and the sinking air gets heated furthermore. So it leads to further higher rating at the further higher rate of heating at the water level, right? So this sinking air column undergoes adiabatic compression and heating. Now, it has also accumulated the heat from the sites. The latent heat of condensation has also been accumulated. Means what? Means it further intensifies the low pressure due to heat. If the low pressure is intensified due to heat, means what? Means more winds will be driven towards that low pressure, stronger winds will be driven towards that low pressure. And around that low pressure, if more winds are coming over, they are going to carry much more amount of moisture along with them, isn't it? They will carry significantly more amount of moisture. So when more amount of moisture is brought, those winds will also rise up in the same path. So what will happen to the existing clouds? The existing clouds will get pushed aside and newer clouds get created. So the clouds which were present and were formed earlier, those clouds will then get pushed aside and newer clouds will come into existence. The earlier formed clouds, they will be pushed aside and fresh and more condensation will happen. Like this, the cloud cover begins to increase and expand, isn't it? Now, as that cloud gets created, basically, so when the low pressure gets intensified, means what? More winds are attracted, more moist winds get attracted, which means what? More condensation, more condensation. When you have more condensation, means more latent heat, is released. Means what? Where does that latent heat get released? It is released in the center, isn't it? So center continues to get heated up, to get heated up, which means what? It will further intensify the low pressure, and this entire cycle will keep on getting repeated. As this entire cycle keeps on getting repeated, what will happen? Slowly and steadily, the low pressure gets stronger and stronger and much more intense. That means the wind speed will get much more stronger and stronger. That is the reason why, as long as a tropical cyclone is above water, it keeps on getting stronger, right? And it is able to sustain itself. It is able to intensify itself, strengthen itself, as long as it is above a water body. That is the reason why a tropical cyclone is also what is regarded as a heat engine, because it is able to sustain that heat, latent heat of condensation. Then also the sinking air provides that heat. So it is able to sustain itself, and it grows stronger and stronger in the process. But then this cyclone, will it be impacted by the surface level winds? Yes. Will it move? Yes. Due to what? Planetary winds. So, in the region where the cyclones are in existence, what are the type of winds in existence? You have the northeastern trades and basically the trade winds, which move from east to west in general direction. That is why the general movement of these cyclones is always from an east to west direction. Okay, so that is how these cyclones get created. In the central portion, this central portion, this is what is referred to as the eye of the cyclone. All the tropical cyclones will always have an eye. But that is not always the case with a temperate cyclone. Few of the temperate cyclones might have this eye, few of them will not. Okay, and then the sides of it, that is what is referred to as the eye wall. So in the eye of the cyclone, you will not observe any cloud formation whatsoever. Why? Because of multiple reasons. First of all the latent heat gets accumulated in the central portion. So central portion is much more hotter. So when the central portion is hotter, for condensation to happen, you require cooler temperature, right? And in central portion, you have sinking air. For condensation to happen, you need, or cloud formation to happen, you need rising air. So that is where it is not having any cloud cover. Observe this. This is your eye of the cyclone as observed from space. It does not have any cloud cover. And this is the region where you will have very thick clouds. That is your eye wall. Okay, so no clouds. So when the cyclone hits the land, that is what we refer to as the cyclone making landfall. That is when initially what happens? We talk about the experience. Initially, you are frequented with a very strong wind motion, right? Because all that wind is getting impacted, moving in a circular motion over a very large area due to that very intense low pressure, right? And the low pressure in itself is moving towards that land. Now, over a period of time, what can also happen? As this comes over to the land, first of all, the clouds, the side clouds, they will bring heavy rainfall. All of these are rain bands. These will bring very, very heavy rainfall. These tell you how in different phases more condensation has happened. So these will bring very heavy rainfall. Then the eye wall will bring almost maximum amount of devastation. All the meanwhile, the tropical cyclone is always associated with a wind speed of around 150, 160, 170 kilometers. When the wind speed crosses 220 kilometers per hour, that is when it is named as a super cyclone. Super cyclone, the highest alert level, that is red, is alert level is put forward. That is where you have maximum amount of destruction. But as one eye wall crosses over, then the eye makes the landfall. And when the eye comes over to the land, that means at that point of time, you won't observe the cloud, right? No cloud, because the eye is free of cloud cover at all the rates. So eye doesn't have a cloud. So when the eye comes over, you will observe clear sky, calm conditions, because you have sinking air. Many people mistake it to be the end of the cyclone, but it is not the case. The remaining part of it also comes over, brings over the similar scale of destruction. But when that cyclone makes a landfall, at that point of time, that low pressure center which is traveling with the cyclone, it doesn't get supply of moisture anymore. Because for the sustenance of this cyclone, for the self-sustenance and the self-strengthening of this cyclone, moisture supply is a must. So that moisture gets cut off when it hits the land. So when the moisture gets cut off, why does the moisture get cut off? because obviously winds coming from the land areas are going to be much drier. They won't have abundant amount of moisture as compared to winds coming over the water bodies. So when the moisture supply gets cut off, obviously that much condensation will not happen. When the condensation will not happen, all that low pressure which was created, low pressure will never be intensified, because low pressure was getting intensified due to the latent heat of condensation. If the condensation is not happening, means no latent heat is being released. If no latent heat is being released, that means what? That basically means that the low pressure is not going to intensify anymore. Plus the region is receiving heavy rainfall, it will cool down, and the cyclone will dissipate. That is why tropical cyclones, 49 out of 50 times, they will dissipate, they will weaken, they will die out within a few hours of hitting the land. As long as it is above a water body, it will continue to grow stronger and stronger and stronger. Longer the time that the system spends over the water body, stronger the cyclone gets. Okay? Now, here, when we talk about the better image overall, so here, if you just a quick recap of it, that what happens initially, you have the heating in this region. Now, heating in this region basically means that you have creation of an extreme low pressure. And that extreme low pressure means the winds get attracted, right? And the winds which get attracted, they also get heated up. These are moist winds. They also get heated up and they start rising. You have acute low pressure. Now, here, let me try an associated concept as well. Let me see if you're comfortable with that associated concept. Low pressure, if it is very intense, can lead to a rise of sea level. Try to digest it. Low pressure, if it is very intense, can lead to a rise of sea level. How? So think about it. When you have the sea, now in all places of the sea, you have the atmospheric pressure which is acting. Imagine a situation where suddenly you remove this pressure in this area. Plus, in this region, you have wind which is coming and having this kind of a motion. So that means in this area, you will observe the sea level to be slightly higher. Temporarily, obviously, but the sea level in that region gets temporarily higher. Okay, we'll use it at a later point of time. By the way, this rise in sea level is responsible for the coastal floodings in many of the cases that you observe, that the cyclone makes a landfall, the coastline gets flooded in that region. It is because in that area where the eye is, that inflated sea level basically floods in the region. So what happens is, in that region of low pressure, the winds get attracted, they rise in that circular pattern. And as they rise in the circular pattern, they undergo condensation all along the sides, right? When they undergo that condensation, they will release that latent heat of condensation in the center. To add to that rising air movement, you have the central portion which experiences a kind of a suction, because all around it, wind is moving in a kind of a closed loop. So it creates a suction, which means the air starts sinking in. So here in this region, you have sinking or subsiding air column. Now that air, as it starts to sink in, it will accumulate the latent heat of condensation from the sides. It will further heat the low pressure, right? It will further heat the low pressure. And that means when the low pressure gets intense, understand the chronology. So when the low pressure gets much more intense, more moist winds will be attracted, means more condensation will happen. More winds, as they are accumulating across the region of the eye, means more water gets accumulated. So a rise in sea level around the region of the eye. More condensation above means more latent heat. The process will get repeated. More latent heat is released means center continues to get heated up. That means it will further intensify the low pressure. All the meanwhile, the central portion will be bereft or will not have any cloud cover whatsoever. Why? Because the central portion is actually heated up. and it has sinking air column. So no cloud cover. That is referred to as the eye. All the tropical cyclones will have an eye. Temperate cyclones might or might not have an eye. So this process continues and the low pressure intensifies, the wind movement keeps on getting stronger. The clouds, they get formed at the center, around the center, and they expand outwards. So the cloud expansion you will observe outwards. These clouds can expand to a diameter of around 500 kilometers, right? And they get created. The cloud cover is so very thick, it can reach up till the top of troposphere as well, around the region of tropopause as well. And the formation can happen immediately closer to the ground surface. That is 2 to 3 kilometers from the ground surface, you will observe the cloud getting created and can end up extending up till the top of troposphere. Now, all these, basically, the disturbance, as long as it is above the water body, it will continue to get stronger. The moment it hits land, its supply to moisture gets cut off, what is referred to as landfall. When its supply to moisture gets cut off, then that latent heat of condensation, further intensification of low pressure, etc., that is not observed. And that means it will lead to an end or the dissipation of the entire cyclonic circulation. So that is what brings about the end of cyclonic circulation. Okay, so that is why when this tropical cyclone makes landfall, hits the land, that is the end of it. Okay, you have certain rare cases such as cyclone Titli, cyclone Tote. Cyclone Tote was the one which hit the Indian western coastline, that is Gujarat and Maharashtra coastline, and it hit from the Arabian Sea. It was supposed to get weaker, but when it hit the Gujarat coastline, it also merged with a low pressure which was already in existence in that region. And because earlier also we have seen cyclonic rainfall is what India receives during the monsoon months. You have those low pressures over the ground surface, and that low pressure combined with the Tote, and it became much more intense. So rather than weakening upon hitting the land, it started getting stronger. And eventually it dissipated by the time it reached Rajasthan. But then overall, as I said, 49 out of 50 tropical cyclones, as soon as they hit the land, they get weaker and they dissipate. So, this is the entire process of the formation of a tropical cyclone. Let me take the questions. I hope that is understood, guys. Let me take a couple of questions before we take a break. Was it the only reason why heavy rains were experienced in Rajasthan major area when Biparjoy? Yes. And low pressure area will undergo evaporation also? Yes. Evaporation will be there because it is a thermal low pressure. Priya, sir, it doesn't create rainfall. It always creates rainfall. It always creates. Which portion are you talking about doesn't create? In the eye will be bereft of cloud. It will not have any cloud. Eye will be free from any cloud covering. Okay? Once again, more condensation happen, more heat. Yes. See, when you have condensation which is happening, Ganesh, why is the condensation happening? Because the moist winds are coming over from the water bodies. These moist winds are rising up, and these moist winds, immediately as they rise up, immediately they will condense, because when the humidity level or the moisture level is high, condensation is much faster. We have seen last week, right? They will reach saturation very quickly, they will condense, and as soon as they condense, they will end up releasing that latent heat of condensation. Where will that latent heat of condensation be released? In the path where the wind is rising. What is the path for the rise of the wind? That circular motion overall, that is the path. So all that heat gets supplied in the central portion, and that further intensifies the low pressure on the ground surface. So in a way, that latent heat of condensation supplied is very essential for the upkeep, and not only the upkeep, the intensification of the low pressure on the water body. Okay. Priya, as in doesn't the eye wall repeals? Doesn't the eye, oh, okay, repels the eye of the cyclone of ground or Gujarat? No. See, the low pressure is existent on the ground in many of the cases. So this low pressure can combine. It can always, so you have also what is referred to as the Fujiwara effect, something which we are not going to cover for the general studies. It was there in current affairs last year, but basically not required for a GS at all. Fujiwara effect basically tells you that when you have two low pressure systems, they are moving with respect to each other. They can either get entangled in a circular motion, they can merge, they can basically come together, collide, and separate again. So there is a possibility of them merging and becoming stronger. Okay, so that is a possibility. When the cyclone is in moist area like in coastal area, how it dissipates? Because the air, see, cyclone in coastal areas, it will attract wind from the land also, from the land portion also. It is not going to be the case that it has hit the coastline at 5 p.m. At 5:10 p.m., the sky is clear and no cyclone at all. When I say a few hours, means if it has hit the coastline today evening, maybe by tomorrow evening, the cyclone will weaken substantially. Few hours as in 24 hours, right? 24, 25, 30 hours, the cyclone can dissipate. Okay. So digest this up. I will leave you up to this particular slide, and we meet again after the break. So we take a break. We come back at around 6:25, and then we will carry on further. Keep your doubts assembled. Immediately after we resume after the break at around 6:25, we will continue with the discussion furthermore. Okay. How global warming, more increased tropical cyclone. Apply your logic, Ganesh. Apply your logic in the break that how global warming can lead to more occurrence of tropical cyclones. Everyone, apply your logic to this question. When we come back, let us see if we have the solution from your side itself. I expect this solution to come from your side itself. Why global warming is leading to increased occurrence or increased frequency of cyclones? I want this answer from you. Take a break. Let's be back at around 6:25, and then we continue.